In lesson 1.5, we're going to be talking about angle relationships. So, in the previous lesson, you learned about angle measure and how we can add two angles to get a third angle, and how we can even sort of subtract angles. And so, now what we're going to do is we're going to talk about relationships that exist between these angles. All right. So, the much of this lesson, it starts off with a lot of definitions and stuff like that, right? So I'm going to be filling you in with definitions. All right, there is, to every one of these definitions, it just seems like there's a way for students to get kind of confused as to what it's saying and what they thought it was saying. So we're going to be talking about that as well. All right. So first thing is adjacent angles. What are adjacent angles and what are not adjacent angles? So your book does a beautiful job of giving you examples and non-examples. Okay. So as far as examples are concerned, an example of an adjacent angle, all right, two adjacent angles is right over here. All right, you got angle 1 and you've got angle 2. Now, you'll notice that they both have a common vertex, all right? They have a common vertex, and if you see it, the common vertex is right here, all right? And they have a common side, so here is their common side. So they have a common vertex, where they have a common side, but no common interior points, right? So notice how whatever angle 1 is opening up into, it's not the same thing as what angle 2 is opening up into, all right? So I would say that if you remember these two things, a common vertex and a common side, that's usually sufficient. It does get the job done. But it does help to know that you're not going to see any interior points that are the same within them, all right? So that's what makes two adjacent angles: common vertex, common point, and no common interior points. So let's take a look at another example. All right, so notice how angle 1 and angle 2, they have a common vertex, which is right over here. And if you don't see the angles, I can highlight them for you a little bit. So here is angle 1, right? And then the other one is angle 2. Right? So they share a common side. They have a common vertex. Notice how the black side and the red side are common. And finally, notice how angle 1 opens up into a section of this page that angle 2 does not open up into. It opens up into a totally separate section. So this makes angle 1 and angle 2 adjacent angles. All right, now, what's something that's not an example? All right, so let's take a look at angle 3 and angle ABC. All right, so we're talking about if we specifically referred, let me get a different color here. If we talked about angle ABC, all right, so here's angle ABC, all right, and then here is angle 3. Okay, now you'll notice that between angle ABC and angle 3, yes, they share a common vertex. That seems to be working out for us. Yes, they share a common side. Notice how BC is a common side that's shared between both of the angles. But what's not true here, they don't have any common interior points. But the problem here is they do have common interior points. Notice how ABC, what it opens up into is this entire section, right? ABC opens up into that entire section of the page, and guess what? Angle 3 is overlapping it. Angle 3 is also opening up into a similar section. And so that's the problem. You can't have that. Therefore, they're not adjacent angles, all right? Let's take a look at another example. All right, let's take a look at another example here. Angle 3 is right over here. All right, and angle ABC is right down here. All right, what's the problem now? I would say neither do they share a common vertex, nor do they have a common side. The only thing that's happening is they have no common interior points. But again, that doesn't matter because if any one of these fails, these are not considered to be adjacent angles. All right. So that's the first definition. Now comes the second definition. These are all very important definitions that you must understand, all right? So a linear pair, all right? So first off, a linear pair is a pair of adjacent angles. So in other words, what you just learned about adjacent angles on the previous slide here, okay, that it has a common vertex, a common side, and no interior points. So a linear pair automatically is fulfilling those three things, right? However, what you will realize is that the non-common sides are opposite rays. Now let me help you understand what that means. Okay, let me help you understand what that means. Take a look at angle 1 and angle 2. All right, so let's go to angle 1 and let's highlight that. All right, so here's angle 1 and then here is angle 2. Okay, first off, notice how they both are fulfilling those three descriptions. They share a common vertex. If you don't see it, the common vertex is right over here. They share a common side. It's pretty easy to see that there's the blue and the red side that's being shared. And they don't have any common interior points. They both open up to separate sections of the page, right? So what makes this a linear pair is if you look at the bottom, right? If you look at the bottom, you'll notice something interesting. And by the bottom, I know I'm telling you is right over here. Okay? Notice that they form a line. And because they form a line, so that's the easiest way to remember what a linear pair is. Because they form a line at the bottom, these are a linear pair, angle 1 and angle 2. All right, let's take a look at something that's not true. All right, so focus on angle ADB. All right, so let's just kind of highlight over that. All right, ADB. And then angle ADC. All right, so ADC. All right, first off, notice how they are sharing a common vertex, which is point D. So that's working out for us. Number two, they are both sharing a common side, so that works out for us. Number three, they open up into different sections of the page, so that works out for us. What doesn't work out for us is we were talking about linear pairs. This is not a linear pair. And the reason why it's not a linear pair is you got to look at the bottom. All right, look at the bottom, and you'll notice that the bottom does not create a line. This is not creating a line for us. And so that's why these are not considered linear pairs. So that's the easiest way to remember this. But if you look at the textbook's definition, you know it is a textbook, so it says non-common sides that are opposite rays. You may go with that if you wish, but I think if you take my my advice for it, you'll find it a lot easier to just look for a line at the bottom, okay? Well, we continue now. So far, we have learned about what? We've learned about adjacent angles. All right, so we've talked about adjacent angles. What do we have here? Adjacent angles. All right. One thing that we've learned about adjacent angles is one of the types of adjacent angles is called a linear pair. All right. And so we've got those two definitions all written out. Now we talk about vertical angles. All right, vertical angles are two non-adjacent angles. They're not next to one another. Okay, so again, let's pause. Remember what adjacent angle was? They had a common vertex, they had a common side, and they shared no common interior points. Now, vertical angles are two non-adjacent angles, and the way that they're formed is by two intersecting lines. So the simplest example I can give you for this is just think of it like that. Just make an X on your paper, okay? Make an X on your paper, and the angles 1, and 2 are vertical angles. And angles 3 and 4 are vertical angles. They're not all vertical to one another, by the way, but 1 and 2 are vertical, 3 and 4 are vertical. That's what we call vertical angles. Or you can look at the textbook definition and try going by that, all right? But that is much grounds to go get confused by it, all right? So here's an example. Well, pretty much use the same exact thing that I did. In fact, it's exactly the same. You've got two lines that are intersecting, right? Notice how these two lines intersect, right, at that point where I just drew. And the angle 1 and angle 2 are opposite from one another. 3 and 4 are opposite to one another. And here is the secret. And one thing that you learn about vertical angles is vertical angles are congruent angles, all right? So just to help you remember this fact, let's just suppose that angle 3, right? Let's just suppose that angle 3 was 30 degrees, all right? Well, then automatically angle 4 would also be 30 degrees. Let's suppose angle 1 was 150 degrees. Automatically angle 2 is also 150 degrees. All right, so that is the secret, is they're both going to have the same amount of degrees. All right, but please be careful. I'm not implying that all four of them are the same. All right, so 1 and 2 are the same, 3 and 4 are the same, and so that's what we mean by congruence. All right, now here is stuff that students, after they have learned this example, they make mistakes with. So I've got two non-examples for you, all right? First off, notice that both of these non-examples have vertices, all right? So that's working out for us. Now, one thing that you'll notice in the top one is you've got the angle AEB, right? Angle AEB, and you've got the angle DEC. Now, these are not vertical angles. And now, why are they not vertical angles? It's because you need to have two intersecting lines. These are not two intersecting lines. You want to look at it carefully. Let's get rid of this. Notice how line AC is one line, but then look at how can a line be crooked like this, right? Look at BED. Those are two separate arrays, right? That's not an intersecting line. And so because there is no intersection of lines, you cannot say anything about those angles AEB or DEC, or by the way, AED and CEB. You can't say anything about them. These are not vertical angles, all right? Now, just a little mention of something a little bit more than that. Um, uh, in this diagram over here, in this diagram over here, that diagram is to the fact that vertical angles are congruent. Okay, so I don't have to explain the diagram again to you because we just talked about vertical angles are congruent. And so notice how ABC is congruent to DBE, and then ABD is congruent to CBE, like that. And so just one thing to highlight though is notice how they have made these marks on those two angles because they're congruent, and then they've made two separate marks on those two angles because those are congruent to one another. All right, so let's go back to our drawing board. What have we learned so far? We've learned that adjacent angles are two angles that are essentially next to one another, all right? But there's, three conditions for it. Then we've learned that a linear pair is essentially an adjacent angle. However, there's a little bit more happening in a linear pair is you'll notice that it forms a line at the bottom, right? Now, when it comes to non-adjacent angles, so it's like a separate category. It's not part of the same category. So let's talk about non-adjacent angles. So for non-adjacent angles, one of the type of non-adjacent angles that you can end up with is called a vertical angle. All right, so this is one of the types of non-adjacent angles. All right, so let's keep moving. I just wanted to show you where we are as far as definitions and stuff like that are concerned. All right, next one. Now we talk about angle relationships as far as complementary and supplementary are concerned. So we haven't done any math so far. Everything has really just been a review, most likely, of things that you learned in geometry in middle school. All right. So let's talk about complementary angles. I think most students that I've taught do know this, so we won't spend a lot of time on it. So it says angles 1 and 2. First off, if you're a complementary angle, the sum is 90 degrees. And if you're supplementary, the sum is 180 degrees. Okay, so that's one little note to make. Now, notice how angle 1 and angle 2, nowhere does it say that they add up to 90. However, there is a symbol down here that represents 90 degrees. And so what it's implying is the following. For some people, this is common sense, but I've seen that for a lot of students, they don't realize, they don't make this connection. And I want to help you, all right, to make sense of it. Notice how the red angle and the blue angle, 1 and 2, they're going to add up to that symbol that was there, and the symbol that was there was the 90-degree symbol, all right? So these are complementary. Same goes for angle A and angle B. Angle A is 65 degrees, angle B is 25 degrees. If you add 65 and 25, you end up with 90 degrees. Now, a lot of students have gotten confused by this one. They're like, wait a minute, these are complementary? Yes. We never said that complementary angles need to be adjacent angles. Nobody ever said that. The problem is we normally learn it like this, so we think that's the only type of complementary. No, it's totally fine for complementary angles to be written out separately. As long as they add up to 90, these are complementary. Well, the same example applies for what we see over here. There's two examples here. Take a look at angle 3 and take a look at angle 4. All right, so in angle 3, you'll notice that angle 3 and then angle 4, they are, all right, so here's my angle 4, all right, they are supplementary because they add up to 180 degrees. Now, if you're wondering, it doesn't say that anywhere, so let me help you out. Notice that on the bottom, what do they form? They form a linear pair, right? They form a linear pair. And if you did not know this coming in, a linear pair is always 180 degrees. All right. If you don't believe me, look at a protractor, and you'll notice in a protractor, if you look from one end of a protractor all the way to the other end. So we've done this, sorry, in a different lesson. If you look at one end of a protractor to another end of the protractor, what you'll notice is it starts from 0 degrees and then it travels all the way to how many degrees? 180 degrees, doesn't it? Right? And so, in fact, one entire line, right? One entire line that's formed on the bottom is automatically going to be 180 degrees. All right? So angle 3 and angle 4, although they're not labeled, they add up to a line on the bottom. In other words, a linear pair, so they are supplementary. Okay, so the last thing to mention here is notice how angle P and angle Q, they both add up to 180 degrees, so they are also going to be supplementary. All right, so back to our drawing board of things that we've talked about, we include now even more definitions, but you want to keep track of where these fall. So you have complementary angles, all right, and you have supplementary angles. So far I have taught you 6 definitions, right? 6 definitions, and 2 of these definitions are pretty much, they're kind of a part of the first definition. But these 2, they could be part of the first definition or they couldn't be, all right? There is no saying. All right, now we are going to take a look at an example or two. So notice how in the example over here, you've got angle 1 and angle 2, all right? And we're telling you that the angles in a linear pair are supplementary. So this is kind of an example, kind of not. The measure of angle 1 plus the measure of angle 2, all right? So angle 1 added to angle 2 are automatically going to give you 180 degrees, And the reason why is because they are in a linear pair. That's it. All right, so that was barely an example, not much to write there. Okay, now let's take a look at the following. It says find the measures of two supplementary angles. So you have two angles that are supplementary if the difference in the measures of the two angles is 18 degrees. So what thing that we understand from this is we're going to have two angles. Okay, so let's call it angle A and let's call it angle B. All right, that's one thing you should understand. Now, if the two angles are being told to us to be supplementary, what did we just learn? Supplementary angles, they add up to what? All right, supplementary angles, the measure of angle A plus the measure of angle B should equal 180 degrees. All right, we understand that. Now, more than that, the question says if the difference in the measures of the two angles, what does the word difference mean in mathematics? All right, and then the measure of those two angles is 18 degrees. So what that means is the measure of angle A subtract the measure of angle B is equal to 18 degrees. Now, some students might say, let's move this degree sign away. Some students might say, can't we do measure of angle B minus the measure of angle A? It doesn't really matter what you call an A and B. Those are two arbitrary angles that you called anyway, all right? So you know that two angles added up give you 180, and then two angles subtracted give you 18. So this is going to take you back into a part of algebra, right? And that's why we're using algebra here. That talks about systems of equations. So what you do is you're basically saying that you have two angles, and if it helps, if the M is bothering you and the angle symbol is bothering you, we're saying that A plus B is equal to 180, and A minus B is equal to 18, right? So what you're trying to do is you're trying to solve the system of equations. And the process that we'll use is called elimination. And elimination, basically what you say is, okay, there's a positive b and a negative b. So if I add these two up, they'll eliminate one another, right? And if you take a and you add it, you end up with 2a. And on the other side, 180 added to 18. So you're always adding things. It just so happens that when you added b to negative b, you got 0. So 180 added to 18 gives us how much? It gives us 198, right? And so after that, you're like, okay, 2a is equal to 198. So if I were to divide on both sides by 2, that's going to give me that a is equal to 99, right? In other words, the measure of angle A must be 99 degrees. And now put the measure together, is equal to 99. And so angle A is 99 degrees, right? Just a little nuance there. So if A and B add up to 180, and we're telling you that A is 99 degrees, you can figure out what B is. You can solve a little equation for yourself. You can say, well, using this part right here, we can say that 99 added to the measure of angle B, let's just call it B right now, is equal to 180. So if we solve this equation by subtracting 99 on both sides, we end up with 180 minus 99, right? And so if you do that, you're going to end up with 81, right? So yeah, 180 minus 100 is 80. So minus 99 is going to give you 81. So there you go. The measure of angle B must be 81 degrees. The measure of angle A is 99 degrees. You may check your work. Notice that the sum of 99 and 81 is 180. So they are supplementary angles. And the difference of 99 and 81 in that order. Okay, so 99 minus 81 gives you 18 degrees. So one of the angles is 81, the other is 99. And notice you can say it in any order that you want. We don't need to know that you call them A or you call them B. We just wanted the measures of those two angles. So they're 81 and 99 or 99 and 81. Your call, but we're basically done with that particular part. Okay, so now what you can do is you can pause the video and you can try this example by yourself. Let's try this together. It says find the measures of two complementary angles. All right, let's pause. What did we learn in today's lesson? Two complementary angles, we know that they sum to 90 degrees. All right, so you know that they're going to add up to 90 degrees. Now, it says if the measure of the larger angle is 12 more than twice the measure of the smaller angle. So there is something going on here. Notice how we don't know what the smaller angle is, right? We don't know what the smaller angle is. So how exactly are you supposed to figure out the larger angle, right? So what we need to do is use, once again, algebra, all right? So what we'll do is we'll do the following. We'll say, let's make the smaller angle. If you like to use x's, you can use x's. Let's call the smaller angle, let's call it x. All right. By the way, you could have used the same strategy in the previous one if you wanted. It's totally your call. If you wanted to use x's and y's instead of a's and b's, that would have been perfectly fine. All right. So let's call the smaller angle x. Well, it says find the measures of two complementary angles if the measure of the larger angle, so the larger angle, all right, the larger angle, let's call that our y. So you got x and you got y. Now, because they're complementary, look, it's the same exact pattern. Because they're complementary, you know that x and y need to add up to 90 degrees. Right? They need to add up to 90 degrees. And once again, we can leave the degree symbol out of it because we're essentially working with algebra here. If you're wondering, how did you get that equation? It's because they said that these two angles are complementary, and I called one of them x and the other y. But this time I'm being a little bit more specific. My smaller angle is going to be called x, while larger one's going to be called y. And the reason why that's important is because of this statement. It says the measure of the larger angle, so the measure of the larger angle is, in mathematics, in algebra, the word is in this context means equal to, is 12 more than twice the measure of the smaller angle. So 12 more than twice the measure of the smaller angle. So that's how you write it. Okay, now to solve this equation, what we can use is something from algebra called substitution. Right? So you were certainly taught substitution in the past. So you want to use substitution. And if you don't know how to use substitution, I can help you here. Basically, notice how it says x plus y is equal to 90. And you can never solve that equation just by itself because there's two things that are unknown. Like, for instance, if x was 40, then y would be 50. Okay, so you still don't know what the answer is. If x was 10, then y would be 80. When I say you don't know what the answer is, you don't know whether x is 10 or x is 40. You really can't tell. But you need the second equation to help you tell. So what you do is you say, well, what I'll do is I'll go ahead and I'll substitute 12 plus 2x into the y. And the reason why that makes sense is because notice how the second equation said y equals 12 plus 2x. So in the first equation, we can take the 12 plus 2x and we can plug it in. So here's what that's going to look like. We're going to have x plus, now let me put it in red for you, 12 plus 2x. So notice how where the y used to be, there is a 12 plus 2x, and there's still an equal sign, and this is equal to 90. So once again, just to prevent confusion, this equation right over here has been updated to look like that equation right over there, okay? And now you just need to go ahead and solve the equation, all right? So what's x and 2x going to combine into? You're going to end up with 3x plus 12 is equal to 90. And you can subtract 12 on both sides, so you'll end up with 3x is equal to, what do you call it, 78, right? And then you may go ahead and divide on both sides by 3. And if you divide on both sides by 3, you end up with 26 for the smaller angle. because recall we had said that the smaller angle is x. So what's the larger angle going to be? Very simple. Just go ahead and plug into equation number 2. If you want to call this equation number 1 and equation number 2, just plug x equals 26 into equation number 2. And so when you do that, when it says y equals 12 plus 2x, this becomes y is equal to 12 plus 2 times 26. That's it. All right. So what do you get when you do that? You end up with 12 plus 52. And 12 plus 52 is going to give you 64. And so the larger angle is 64 degrees. The smaller angle is 26 degrees. And here's one thing very neat. Take 26 and add it to 64. What do you end up with? You had to end up with 90. You see that? Okay? So these problems, they start off with geometry. You're going to start to get used to this in this course, is these problems, they start off with geometry, right? But why is it that you were taught Algebra 1 and pre-algebra before you were allowed to take this formal geometry course? Is because many times as you're learning geometry, you need to go backward and you need Algebra 1 and pre-algebra in order for you to move forward with the geometry part, okay? All right, now we have a few more slides here, which honestly it's going to be using more of algebra than anything. So now we're going to talk about perpendicular lines, okay? So in perpendicular lines, what basically ends up happening is they are going to be two lines and they form right angles, all right? They do intersect, all right? And they are considered to be forming congruent adjacent angles. Anywhere you look, you'll notice that these are adjacent angles. All four angles are adjacent to the one next to them, and they are all congruent. Now here's what's interesting. If they are all congruent, and I told you that one of them is 90 degrees, what does that imply about the rest of those angles? That means every single angle is going to be 90 degrees. So two perpendicular lines form that automatically, all right? And then it says segments and rays can be perpendicular to lines or other line segments and rays. The right angle symbol in the figure indicates that the lines are perpendicular. So I think a lot of this is just review for you anyway. But just remember that that perpendicular symbol is this one over here, all right? So when somebody tells you that line AD and line CB, and then they put that symbol there, that means they're perpendicular, i.e. they look like that right there, okay? They form 90-degree angles everywhere. Okay, now let's go ahead and apply this to, once again, into algebra. You see that? So it says that you've got to find x and y, all right, so that PR, so let's highlight PR. Let's go to PR. PR is the line over here, and then SQ is the line that is over here. Now, you want to make sure that those are perpendicular. So if they're perpendicular, one thing that we've learned is you may now go to every one of the angles that's created. There's going to be four angles that are created. 1, 2, 3, and 4. Every one of those angles, remember you only have to put it on one of them, is automatically going to be 90 degrees. So using that hint, right? Using that hint, your job is to figure out what is the value of x and y. You may pause this video and try this by yourself because I have confidence that many of you can do this by yourself, all right? So here is the clue. You want to find what x is, right? You want to find x is. So first find x in the diagram, all right? Notice how there is an x right in this angle right here in STW, and there is an x mentioned in RTW. But isn't there a relationship between those two? And the truth is that if you were to take the two angles STW and RTW, they're actually complementary to one another, aren't they? Because look, they add up to 90 degrees because of the fact that we know that each one of these sections is going to be 90 degrees. So you begin by writing down that 2x plus 5x plus 6 must equal 90. And guess what? That is going to help you solve for x. So you end up with 7x plus 6 is equal to 90. Subtract 6 on both sides, so you end up with 7x is equal to 84. And then you simply take 84 and 7, and then you divide them out. So when you do that, you end up with 12. So the value of x is actually equal to 12. And one thing that students tend to confuse is they're like, wait, how did you know you're supposed to equal it to 90? And that's where you have to read the question. They told you that this is perpendicular. So if it's perpendicular, then automatically whatever sections are created are going to be equal to 90 degrees. Not one of them is 90 degrees, but the two added up need to add up to 90 degrees, like that. Okay, now finding y is actually a little bit easier because notice how y is only mentioned once, and it's mentioned over here in angle PTQ. Because angle PTQ it must be 90 degrees, and they told you that the expression 4y minus 2 is the expression for PTQ, you make the following connection. You say, well, then that means 4y minus 2 is equal to 90. Now, from experience, I can tell you students really find that to be difficult to make that connection. So if you're already making that connection, you're like, yeah, that's not that hard to do. That's really good news, okay? But for those of you who are struggling with it, don't worry. It just takes a little bit of time and you get used to it, all right? Now, you go ahead and you add 2 on both sides. So you end up with 4y is equal to 92. And then you may go ahead and divide on both sides by 4. And so 92 divided by 4 should give you, let's see here, 23, I believe. All right, you may check with a calculator. And so you end up with the value of that as well. All right, so what was the pattern here, right? What was the pattern here? You need to use the geometry. Let me remind you again. You need to use the geometry and what you learned in geometry to set up a relationship. So the relationship that we set up in the first one is we said 2x plus 5x plus 6 is equal to 90. That is the relationship that we set up. That was you using your geometry skills. But then after that, you need to use your algebra, and the reason why you need to use your algebra is because you need to solve that equation, all right? So with the two together, you can get through almost any problem. All right, let's pause here, and I'd like you to take a moment and try this question by yourself. Okay, suppose the measure of angle D is 3x minus 12. So something has already been given to us. It says find x so that angle D is a right angle. Now, here's your geometry skills, okay? What have you learned in geometry? If something is a right angle, what does that tell you? The answer is it should be equal to 90 degrees, right? So if angle D is 90 degrees, and you've been given an expression for angle D, you've been told that angle D is 3x minus 12. So you know two things about angle D. Number one, you know that it's 3x minus 12. Number two, you know that it's 90 degrees. So the connection that you make, and this takes a little bit of time for students to do this, is you say, well, then that means 3x minus 12 is equal to 90, right? Because two statements were made there, and therefore you can go ahead and solve an equation. So add 12 on both sides, and you end up with 3x is equal to 102. And then you can go ahead and divide on both sides by 3. So you end up with 102 divided by 3, which is going to give you 34. So the value of x is 34, like that. Once again, only knowing geometry is not sufficient. You need to be able to do the algebra. But only knowing algebra is also not sufficient. You need to know the geometry. If anything, the geometry is your foot in through the door, and then the algebra is the thing that helps you solve the equation that you were talking about. All right? The pattern that you saw in this, you're going to see a lot, right? Like, let's suppose that there was a person standing here. Okay? Let's suppose, I'm not very good at drawings, but just to help you, suppose there's a person standing, all right? And I walk up to you and I tell you that there is a person standing right there, and their name is Bilal. Okay? And so what you do is you're like, okay, so that person right there, their name is Bilal. I got that, right? And then I tell you that the person standing over there is 4 feet tall. I don't tell you that Bilal is 4 feet tall. I tell you the person standing over here is 4 feet tall. What's the connection you make? You make the connection, well, then Bilal must be 4 feet tall. You see that? So that's precisely, that logic is so important for you to understand. When we told you statement A and we told you statement B, for you to take them and make your own statement is what requires the thinking, all right? And it takes everybody a little bit of time to get used to it, but I promise you, once you get used to it, it is quite rewarding, and you get a lot of questions correct in this course by doing that. Okay, now let's just take a moment and discuss this over here. When you're going to be looking at diagrams, and you're going to look at a lot of diagrams, okay, there are certain things that you can assume to be true, right? Like normally in class, this is a very interesting discussion that I have with students, is I'll ask them, what are some things about life that you can assume to be true, right? Like, for instance, um, no one's going to ridicule you if you say that the sky is blue, all right? I don't think anybody's there to argue with you on that, right? There's already people who say that the earth is round versus the earth is flat, so even that can't be assumed, right? However, without going out into a further discussion. So it says all points shown are coplanar. So in other words, everything here is in the same plane. All right. What else can you assume? Meaning it's automatically true. G, H, and J are collinear. So if it looks like it is what we're trying to say to you. All right. Lines HM, I don't want to highlight these, HL, HK, and GJ, they all intersect at point H. And so, sorry, the first three were raised. They're not lines, right, to be technical about it. So those three lines, those three rays and this line, they intersect at H. So that's something that we agree on, all right? It can be assumed to be true. No one needs to tap you on the shoulder and tell you that, okay? So we understand these three statements. Now, H is between G and J. We get that too. All right. L is in the interior of MHK. So notice how MHK, it opens up, and L is a point that is within the interior of where it's opening up into. All right. GHM. All right. So GHM and HML. So sorry, MHL right here. They're adjacent angles. We agree. GHL. Now this one I really want to highlight for you. GHL. And I'll erase the highlighting in a moment. And LHG. LHJ. Sorry. LHJ. Let me take a moment. Highlight over that. They form a what? Linear pair. You can assume that. No one needs to tell you that. If it looks like it, then it is it. All right? Those are things that you're allowed to assume, because you're going to hear a lot of things in geometry. A lot of people in geometry will say you can't assume that. So what are things you can assume? You can assume that. Now, GHK and KHG are supplementary, right? So JHK and KHG, those are considered supplementary. That's perfectly fine. Okay, so these things you can assume to be true. All right, just like saying the sky is blue, it's okay that to say that this is true. Now, what are things that students tend to make a mistake with? These are really the reason why this section was written is because these are common mistakes. All right, oftentimes students think that this is actually true when it's not. Okay, so number one, you cannot automatically, by looking at this diagram, just say that HM, all right, HM and HL are perpendicular. You just can't say that. Listen, even if they looked perpendicular, you cannot say that they're perpendicular until and unless you don't see the little perpendicular symbol. Until the perpendicular symbol has not been made for you, okay? If you don't see the symbol, they're not going to be considered to be perpendicular. You must see the symbol, all right? Next one. You can't assume things are just congruent. I'm just going to give you a general advice here. Okay, don't think that any one of these, just because it looks like, yeah, you know, JHK kind of looks like GHM, you can't say that. You can't say that these are congruent. There needs to be the symbol. If the symbol is not present, you may not assume that the two are actually congruent. All right. And then the same thing, and most students don't make a mistake with this set, but you can't just say, yeah, GH and HJ are congruent, meaning this segment is similar or exactly equal to that segment. Most students don't make these mistakes, but you know, I'm putting that in the common mistake section even then. Okay, so um, unless and until there isn't markings, you cannot assume any of these three things. You need to have the symbols for you to assume those three things. However, without any markings at all, it's perfectly fine for you to assume everything that's in that box right there. Okay, next slide. It says determine whether each statement can be assumed from the figure, and then it says explain. All right, so let's go ahead and apply what we learned in that previous slide. It says, can you assume, all right, can you assume that KHJ, right, KHJ, that angle right there, is complementary to the angle GHM, all right, so GHM. Can you say that those are complementary? Absolutely not. All right, you cannot say that. And the reason why you cannot say that is because they don't add up to 90 degrees. They don't add to 90 degrees. They don't form a 90 degree, and you don't know because what if one of them was 20, the other one is automatically 20? Well, you still don't know whether that is true or not, right? So because they never put any numbers, you can't say that they're complementary. By the way, it's okay that they're separated from one another. We learned about that in the previous slides. Is it's okay if the two angles are not next to one another. They don't have to be adjacent. They could still be complementary. But the problem is we don't know how much their values are. So we can't say that. We can't assume that. Right? Because there's always going to be somebody who's going to say, wait, what if it was like this? You're right, that's the problem. There's a what if in your statement. There can't be a what if. It must be absolutely true for you to actually assume it. All right? Now, let's go to the next one. It says that angle GHK, all right, so angle GHK, let's go ahead and highlight that. GHK is right over here. And JHK. So JHK is over here. Can you assume that those are a linear pair? And if you go to that previous slide, we said that it is okay for you to assume something that looks like a line to be a linear pair because J, H, and J were collinear. So if you look at this, notice that the 3 points, let me use a different color here, the 3 points G, H, and J, they are all collinear. Because they are collinear, we can go ahead and assume that those two angles do form a line, and so, yes, all right, that is perfectly fine. And if you want a statement, the statement is G, H, and J are collinear. We can assume them to be collinear. All right, letter C. Letter C says that you've got HL, ray, right? So let's highlight ray HL. Here is HL, that's that ray right there. Ray HL is perpendicular to ray HM. All right, where's ray HM? It's right over here. Can you assume that the two are perpendicular? And the answer is yes, you may. And if you're wondering how, it's because there is that perpendicular symbol that is present there. And the perpendicular symbol being present, we can go ahead and say yes, because the perpendicular symbol is present. All right? So this is a very important thing. After you learn all these relationships, it's easy to go wrong and start making up relationships in your head. So you got to make sure that if there is a relationship that you are not assuming something you're not allowed to. Okay? Finally, I would like you to take a moment. This is the last section of the lesson. Take a moment and try this by yourself, and then we'll try it together. A little quicker. Angle GHL. All right, so GHL and LHJ. LHJ. Can we assume that those two are supplementary? And the answer is yes. Why can you say that they are yes? Is because they form a linear pair, and if they form a linear pair, recall automatically they are considered to be supplementary because a linear pair adds up to 180 degrees and supplementary also adds up to 180 degrees. So the answer is yes. All right. Let's go to letter B, and that's the last part of this lesson. Letter B says GHM. So I know it takes some time, but I'm just highlighting these for you so you can keep track. GHM and MHK. All right, MHK, like that, are adjacent angles. So recall, to tell if they're adjacent angles is they need to have a common vertex, and that is happening. The common vertex in this situation is going to be H, so that's a check. They also need to have a common side. They need to be sharing a common side. And is that happening? Absolutely. Notice that right over here is a common side. And finally, they both open up into, they don't share any common interior points, meaning they basically open up into two separate sections of the page. Notice how the black angle is opening up into this section of the page. The blue angle is opening up into this little section of the page, right? So they're not overlapping with one another, and so that is also check, all right? So if you want a writing of it, no common interior points, all right? So that is your reasoning, and so you can go ahead and conclude yes, and when it says explain, that is your explanation. If you don't write the explanation, unfortunately, in high school, we are all about explanations, and you do lose some points. So please don't just go over the explanation saying that doesn't matter. All right? Good luck in completing the homework, and thank you for listening.